Welcome to everyone. Thanks for joining us for our second half of our Evolution of the Smart Meter webinar series. We've got a lot of information today to cover, but we're going to keep it to about 30 minutes today. So if you've got any questions, we're happy to answer them. There's a chat box at the bottom if you can submit them there. If we don't have a chance to answer them today, we will follow up with you. And you can reach out to us if you've got any questions afterwards as well. We've got Dave and Ross joining us again. Ross Malme is the inventor of the world's first and most successful radio frequency utility meter. And Dave Hyland specializes in smart grid strategies, demand response, and supply management. Thank you both for joining again.
Thanks for having us.
Thank you.
Absolutely. Last session, we discussed a lot about the development of the meter, right from the very first meter all the way up to the first drive-by radio frequency transmission meter. We touched on some of the drivers for those changes and some of the impediments, as well as the impacts of and on regulations. And today we're going to continue into the 21st century. And this is a time where there's a lot of things that are pushing the industry from this AMR technology into AMI. Before we get to all that stuff though, let's get some definitions sorted. Dave, can I ask you, can you define for us what's AMI, what's AMR, and really for that matter, what's a smart meter?
Smart meter. Yeah, thank you. Yeah, it's been confusing over the years, especially for people that aren't in a meter shop at a utility, and especially regulators. AMR, advanced meter reading, is basically a one-way out of the meter read that gives the utility the number of kilowatt hours used, and it's pretty basic. Houses, for example, or residential meters basically gave you a monthly reading. Sometimes on the commercial industrial meters, you would get 15-minute increments. It all depends on how sophisticated the meter was. Then we evolved into AMI, advanced metering infrastructure. And what's interesting about that is you still had a meter, but beyond being a one-way meter, it was a two-way meter. So basically, it's the infrastructure that was set up for bringing the data in. So with AMR, typically you'd either have cellular or somebody walking a beat and plugging into a meter and taking the reads. Advanced metering infrastructure basically had some type of network that it attached to and communicated with the meter. And then of course the meter, we've all heard the term smart meter. Smart meter is kind of a misnomer because there's no smarts in a meter. It's basically collecting information on usage and then sending it out to the AMI network, or the advanced metering infrastructure network, back to the utility. So there's been a lot of confusion, but hopefully that clears it up.
Yeah, thank you for that. So once we've got some of these definitions, Ross, can you tell us why is there even this need to go from one-way to two-way communication? What are some of the drivers, and especially in the electric industry, this is where it's most applicable. What are some of those drivers that created that change?
Sure, Ellen. You know, early on, the metering industry for decades and decades and decades were dominated by the big four, and it was, you know, the hardware manufacturing business really. When we started making this transition to AMI, it became more of an electronics business, and it became less about building a product and more about building a solution. And then that caused several of the big guys like GE, for example, to completely get out of the business. And we had a lot of innovation going on. There's a lot of startups and early stage companies that came in. A lot of failures of those companies. The other thing that sort of drove this in the early 2000s, and both Dave and I were part of this, is the introduction of wholesale and retail competitive electricity markets. And we need to share information among several parties, not only the utility, but also retailers, and so in some cases, ESCOs as well, which the retailers, in order to price their product, they really needed to have this this 5-minute or 15-minute or 30-minute interval meter data, which wasn't easily available to them in the AMR business. And they need to have it in a fairly short time frame. Also we had this need when we introduced these markets. You know, electricity is this goofy thing. It's hard to store. Or I'll say today it's expensive to store, and it is one of the most volatile, maybe the most volatile commodity on the planet. So there's a lot of risk in that electricity business for a wholesaler and a retailer, and they really needed to be able to implement time-sensitive rates. And actually, in doing that, you're transferring some of that price risk to the end-use consumer. Also, we started implementing renewable energy, most notably wind and solar, on a massive scale. And if the electricity market wasn't already price volatile, the introduction of wind and solar on the scale introduced more volatility into those markets, because, as you know, the wind doesn't always blow and the sun doesn't always shine. One of the other drivers I'd have to say is, from a technology standpoint, is this whole movement towards IoT. It became just less expensive to go build an AMI meter. You know, if you take a look at, you know, these things right now, there's more power in that cell phone than was on the Apollo space shuttle, the computing power. And so we had the ability to put more computational power and more features into the meter. And from a policy standpoint, a couple of things happened. You know, I think most notably, the thing that moved the dial in the U.S. here was something called the American Energy Independence Act of 2007. And basically that said that only any wholesale product or market that's available to the supply side has to also be available to the demand side. So customers needed to be compensated if they had, you know, generation behind the meter they were delivering into the wholesale market. And customers could participate in wholesale markets like capacity markets or even grid balancing services. And you needed to have near real-time meter data for that. The sort of implementation of that legislation of 2007 was the FERC Order 719. And it basically said to the wholesale market operators, you shall give access to retail customers to these markets. And that became a huge boon for the advent of the modern day demand response industry, and a company that I actually founded in that era and sold to Schneider Electric in 2008. But it's, all these drivers made a lot of sense. The regulatory activity was pushing it, but it was still pretty expensive for utilities to deploy it.
Yeah, yeah. And I think also, you know, the electric market as a whole the pricing doesn't reflect the wholesale market. If you go to the gas station to buy gas today, I just went, as a matter of fact, because I know that later on this weekend, the price of gas is going to go up because of a hurricane. But just because there's a hurricane doesn't mean you pay more for electric. So it's kind of a false market that the utilities have. So it's an interesting phenomenon.
Definitely lots of reasons, especially on the electric side there, to move towards AMI, where they can really have a better handle on all of this stuff. Dave, can you talk us a little bit more through of the business case, especially like the costs and benefits side of it? Because I can imagine there's also some issues that need to be addressed with this business case too.
Yeah, the cost aspect. When utilities started looking at the advanced metering infrastructure, and it was interesting because at that time, in the beginning, the only benefit was to read a meter. And a lot of people would say, well, we got guys on the street, they can read a meter, or we can have a customer read a meter, or we can do a drive-by and read a meter. We don't really need anything else. But with the technology that evolved, a lot of consultants out in the industry were going to utilities and saying, hey, this is the next best thing to give customer satisfaction to your customers, where there's more transparency in pricing, if you have variable rates, energy use, promotions, and whatever, in demand response. So the whole idea was the technology's there, let's put something behind it. And so all these new products came about, and the utilities were really counting on AMI and that network to be able to control and be able to share information with customers. But at the early beginning, it was the utility thinking they knew what the customer wanted. And what a lot of utilities found out was they started moving in a direction, offering products to customers, but they never really got involved with actually interviewing customers and saying, hey, what do the stakeholders want? First of all, what do the customer want? What does the state want? The people that do the legislature, what do the stakeholders want? So consequently, what happened was utilities rolled out these AMI programs, and they really never adequately provided for education of the consumer. So the consumer got hey, this is a neat system or a neat solution, but they never really understood the benefits of it. And maybe even the utility didn't understand the benefit of it. So there was there was increased pricing because the cost increased, but the value really was the same. A customer walks into their house, turns on a light, and that's about all they think about it. So the value was not really created in the mind of the customer. It was a very difficult time, and as AMI continues, a lot of times the customer still doesn't have an education as far as how they use electric and what they do with it. So when those systems were rolled out, there was, on a cost aspect, the decision to use private network, which would be a radio system throughout a distribution system or a service area, or versus going with a network such as a Verizon or an AT&T, somebody like that. So there were a lot of trade-offs that utilities were looking at, and they had a lot of decisions to make, and a lot of them rolled out pilots, hoping that when they did a pilot, they could figure out if they picked the right system or not. So it was pretty tough time for most utilities.
Yeah, Dave, I'd maybe add a couple of things to that. Being an old metering guy myself, I remember back in the early days, utilities would depreciate these systems, over typically 30 years, and
right.
maybe even expect a meter to last 50 years. But as you start to look at these newer technologies, even though the product might function for 20 years or 30 years or 40 years, the technological obsolescence is going to be more like 10 years. So you got to look at a change of a depreciation cycle, and your business case has got to reflect that too. That you're not going to get benefits for maybe over 10 years. At least you shouldn't maybe put that in your base business case. And I think you touched on this, and I just wanted to just reemphasize this, that it's a big deal trying to make the decision when you're going to AMI, whether or not that backhaul network is going to be a public network or a private network. There's certain advantages and certain utilities that really want to have a private network that they can control. It may end up being a little more expensive, and you may have to have the capabilities of maintaining networks like that versus going with a public network like an AT&T or Verizon, 4G LTE or whatever. But it's a pretty big decision, and there's each, I'm not saying that one's better than the other, but it's something that everybody has to put some time thinking about.
Yeah, a lot of times these utilities, they would go back to their commissions, and they would get a waiver on their depreciation rates of the asset. So instead of saying depreciating a meter over 20 years, the commissions would say, okay, we're going to let you depreciate this asset in 7 years, which would increase exactly what they could write off as far as a business expense. So a lot of things changed, and a lot of back and forth with commissions, and nobody really had the right answer.
Yeah, one of the things they always wanted to avoid, and sorry, Ellen, for time, but there's a sort of a third rail in the utility industry that you really want to avoid, and that's something called stranded cost. And if, for those of you that aren't familiar with what stranded cost is, it's when the utility makes an investment with the best of intentions, and for some reason that asset becomes obsolete or unusable before it's depreciated out, and you've got this asset hung up on the books, and the question is who's going to pay for it. So one of the things in AMI you want to make sure is from a technological obsolescence standpoint, you don't end up with stranded costs that either the shareholder is going to have to eat or the ratepayer has to eat.
Yeah, and that just contributes to what you guys were saying before there with, I mean, this is a very capital intensive technology change for a utility. Dave, how did utilities deal with that, especially when this very first rolled out and a lot of those benefits weren't clear?
Yeah, well, there was a gift from the government. I guess we'll call it that. It was the ARRA, American Recovery Reinvestment Act in 2009. And it was where the federal government was trying to stimulate innovation into the utility market and probably in a lot of other markets. So what they did was they offered money that basically they would match any type of project or program, 50% of whatever the cost of the project was. So a lot of utilities said, okay, we want to do AMI and move into bring that into our utility. So a utility would say, okay, it's $1 million. They get half of it paid for by the federal government. What's unique about that is utilities were stuck. If they didn't go and apply for the money, basically free money, they got hammered by a commission and their shareholders. And if they did, then they still had all the issues they had. So it was a really tough time for most of the utilities. It was about $4.5 billion out in the marketplace, and that's what really kicked off a lot of the AMI. Maybe even before its time, before the education and the technology was really up to the speed that it really should have been.
Yeah, that's a very good point. So considering that, especially now that we've had it implemented for several years, what are some of the lessons learned? Ross, can you talk us through some of the technology changes because of those lessons learned now that we know more about a full AMI system?
Sure. As Dave mentioned, the ARRA was a big shot in the arm to the industry. And, there was I'll say a rush to get the money, so to speak, from the utilities. And I remember back in 2009-ish, if you went to Distributech, and you went to one of the meter vendors' booths, and it was all about the hardware. I mean, it was all, about my hardware does this, my hardware does that. And nobody was really thinking through how much data are we actually going to generate here, and what are we going to do with it. So there was a lot of business cases that were developed with applications where people really hadn't thought through all the linkages and the latency issues for those applications. And as a result, when we got a little further down the road, we ended up with some systems that had some huge data latency problems. You just couldn't haul the data back fast enough to support the application. And that sort of ends up with the third rail thing I talked about earlier. Systems that could be be looked at as stranded cost, and you maybe have to replace them before you wanted to with the next generation of AMI. But a lot of technologies were developed. There were mesh technologies for meters that were developed, and some of the majors still deploy those. There's some Wi-Fi was integrated in some meters to be able to talk, in-home networks. I was just talking to a colleague of mine, and now that's if you think about some of the issues that we experienced during the COVID here, with rural electric cooperatives and customers served by them with their kids all at home, trying to do distance learning, and they don't have adequate Wi-Fi or broadband, and there's a huge push going on right now to bring broadband to rural America, and there are programs for that. This particular company is able to integrate fiber optic and a form of metering with fiber optics, which is very attractive. for the cooperatives. And I think about probably the most well-known business case for that deployment with ARRA is Chattanooga, Tennessee. They effectively built a 2 gigabyte pipe to every customer they have, and it was almost one of those build it and they will come, and that's exactly what happened up there. Is the companies like Amazon and others are moving data centers to Chattanooga because they've got all this connectivity. Over the last 5 years, I'll say, there's a number of the utility commissions have been pushing really hard on what we call grid modernization to increase resiliency. And it's due to weather impacts of hurricanes, flooding, and so forth. And probably you remember the last hurricane that came up the East Coast. There was a huge blowback on a couple of utilities on the East Coast that they hadn't invested enough in resiliency of those networks. But that sort of goes beyond measurement and control, even beyond AMI, as we now are deploying all these DERM systems, distributed energy resource management systems. Basically, the utility is blind, on what's happening on the customer side of the meter, and so there's a huge push for measurement control at the edge of the grid. And then I'll probably say the last thing that we're seeing right now is, in particular in California and Hawaii, where you've got such a huge penetration of solar PV. We have this thing called the rise of the prosumer. So you're not only a consumer of electricity, but at times you're a producer. And not only do you have to have AMI now, but you have to have AMI that goes both directions. So you might be putting power out on the grid and at one point in time, and then taking power back, which will probably at some point in time get us to something called transactive energy, which is probably a topic for another webinar. Ellen, you're on mute.
Before that, yeah, I got that. Yeah, so lots of new use cases that have come out of it, lots of proving out what some of the benefits are. Every one of those use cases, though, requires a lot more of the systems and applications in the background on the IT side that we mentioned earlier. I can imagine that can be very difficult for some utilities to make that business case work with the amount of changes that have to happen to accommodate all those use cases. Ross, are there any hybrid AMR technologies out there that give some of the benefits but don't have all of the costs associated with AMI?
Well, yeah, there's a few that are out there. One of the, we still have drive-by AMR is deployed on countless utilities across North America, and one of the most effective ways to reduce costs is to transition eliminating vehicles on the street and collecting meter reading airly. That's what your company clearGRID does. You're able to collect meter data from an aircraft at literally a couple thousand feet in the air, and it reduces cost. It increases safety and getting utility people out of the field in this era of COVID and social unrest. It also helps decrease the utility's carbon footprint. And I think even for in the long term for gas and water utilities, this solution might be a permanent solution for them. And once you launch an aerial platform like this, you can not only use it for meter reading, but for other utility data collection applications like cathodic protection on pipelines. You can use it for inspection of infrastructure like transmission lines and so forth, going forward.
And Dave, how about your take on the future of AMR and AMI? Where do you see the industry going?
Well, if you look at that graphic that Ross just had up, you had kind of a hybrid approach to AMI, and then having all the wonderful things that value stream that goes with it, such as demand response and controlling different devices in your house. To get away from that hybrid, most of the AMI systems that are set up right now, or the networks, they don't really do demand response and control devices remotely over the AMI network, because the people that own those networks like to keep those networks specifically for AMI, and they don't want to have any downtime for the most important thing that those networks do is read the meters for the utility. So what we're seeing is a move towards something like a 5G, where you're going to have a whole lot of data that can be transmitted both ways. So you got prosumers generating electricity, putting the electric into the grid. The utility will, with the 5G, will have the capacity to go in and actually see what's happening real time. And then also with the 5G going to people's houses or companies, they can actually control devices remotely. So I guess the transition would be like from, and I'm going to date myself, the old days when you had a computer and a modem that the thing with AOL screeched and made all kinds of noises, to now it's you click your mouse and next thing you know, you're off on Amazon, you're looking at books and all kinds of things. So I think that transition is going to be faster, less expensive, and more optionality as far as offering products and services to customers to keep those customers happy. Now, there's some areas that are still a problem. Rural areas, they don't have the infrastructure that a city has. So, for example, you might not get 5G out to a rural area. So you might still have some power line carriers, some things like that, or aerial meter reads, things of that sort. So it all depends. By the time 5G gets out to the farmlands, we're probably going to be up to 7G. So the obsolescence of communications is a major factor. So companies need to plan for that.
Yeah, David, one thing I'd also point out, you mentioned 5G, and I think I agree with you. 5G is going to be a huge game changer, but for utilities, I mean, there's a couple of considerations for them. 5G you have to have antennas effectively every 150, 200 feet, which right. means the 5G providers have got to get pole attachment access, or either to utility poles or light poles or some infrastructure, and it creates an opportunity for utilities to create a new revenue stream. So they need to have a strategy around how are they going to deal with the attachments to their poles, and also I'd also point out that you got to also make sure that your vendors are going to have the products ready to roll out when the 5G networks go out there. So it's not it's a kind of a chicken and the egg kind of thing. And I think that every utility, at least every utility in the metropolitan area, has to have a 5G strategy that also should probably dovetail into what's the smart city strategy for your city in terms of what applications are you going to deploy. In fact, I just saw a project that LA is rolling out right now where they're going to turn light poles into I'm going to call it the Swiss Army knife of smart grid applications, where you're going to have various adapters for plug-in vehicles, for PV, for gunshot detection, for air quality detection. Of course, in California right now, air quality detection, all you have to do is look outside. But it's a really cool project. I hope they move forward with that. But it's the need for utility as they deploy these things to say, okay, who are my partners going to be? Who are my customers going to be for this thing?
Right. Yeah, the utility pole won't be just for delivering electricity in the future. There'll be all kinds of things on that pole.
Wow, some exciting stuff there. We've hit our half-hour mark here. I just want to let everyone know before we leave, we do have another webinar coming up October 6th at 1 p.m. Eastern. We're going to explore 21 different uses for meter reads. So really good tie-in to these sessions where we all know that meters are there for billing the customer, and we've heard some of the other use cases in these sessions, but we'll explore a variety of different ways that utilities are using the data collected from meters. So Ross, Dave, thank you again for joining us. Thank you everyone for joining us, and I hope you all have a great day.